Hello and welcome to this video. In this video, I will be discussing the command sequencer, or basically the command engine of the CubeSat. So a long time ago, there's a video that I made discussing the flight software architecture of this CubeSat, and for the past couple of days I've been building this command sequence, and I'm going to show you just what I've come up with. Is a very basic flow. It's not really up to industry standards, but we'll worry about the industry standards and the flows and whatnot later on. But right now we have like a simple working prototype of this command sequencer engine. So basically this is what I'm going to show and see whether we can discuss a little bit of code and how I have approached the design. So basically what you see here is my simple flowchart of how I expect this to work. So initially there's a command, right? There is a command that we are sending to a satellite, right, from whichever place. Ideally, I want it to send it from my ground station. So once the CubeSat is like connected, there's a downlink, then I can basically transmit and receive data and commands from the CubeSat. So that's a command type, right? So that's a satellite command. So a command has two types based on what I've come up with. There is a immediate command and a scheduled or scheduled, whatever command. And then there is the command string itself, right? There is the command string itself. So this is what constitutes a command. Now next we receive the command from ground station. After that we check which type is it. Is it an immediate command or is it a scheduled command? If it's a scheduled command, I'll discuss that. If it's an immediate command, that's what I've built right now. We tokenize it. Basically, tokenizing means that if it's a string of characters, let me just open my notepad just to explain that part. Good. So I have some examples of commands here. So for example, these are two types of commands, right? There is the EPS restart and then the time, this time right here. I think I modified this time to be UTC, so EPS restart at this time. So this is a scheduled command. Basically, it is telling the CubeSat when we get to this time, this is UTC, so in the firmware you will convert this to your time zone, whatever time zone you're in. Once we get to this time, I want you to restart the EPS. So there are three things here. There is the subsystem that you are targeting. In this case, is the EPS, and then there is the restart. There is the command to execute, right? Which is in this case restart. And then there is the time, right? Which is now this time right here. So this here is a scheduled command. So I always find it hard to pronounce that word. Scheduled command, right? Then there is the immediate command. Immediate command is like once it's received, it's just executed there and then instantly. For example, this command sleep, right? So if I paste that, you see it has almost the same signature. The subsystem is the EPS, the comms. So this is comms, and then there is no time, obviously. Then the command is to sleep, right? So these are the two types of commands or command types that I have, scheduled and immediate. Okay. So if it's an immediate command, we tokenize it. So tokenizing is basically getting this part and getting this part. And then I'll show you that in the code I put them in like an array of strings, right? So we have comms, sleep, and if there are other parameters, we put them there. That's tokenizing. After tokenizing, we validate now, like is the comms even a part of our CubeSat? And validate the command. Is sleep a part of the allowed commands? Right? That's what we mean by validating. So if the subsystem is not okay, say not valid, it's a mistake there, not valid. If it's not valid, we discard the command and just move on. If the subsystem is valid, we validate the command, and after it's validated, we now send to specific subsystems queue. So the architecture is that once you receive a command from, let's say, the ground station, and that command is meant for the EPS, right? If it's, for example, it's meant for the the EPS subsystem or the code itself has a command queue, right? There's a command queue that receives any command from the command engine. So those commands that are sent to the specific subsystems have their own command handlers. Primary or rather isolated, there's a word I'm looking, localized, good. They are localized to the subsystem. So if the subsystem is EPS, that command will be sent to the EPS command queue. If the system is comms, this command will be sent to the comms command queue. Right? So it's a more of a switching or routing mechanism here. So after you send it to the subsystems queue, subsystem command will handle, or rather the subsystems handlers will handle the command. And then if the execution, once the execution is finished, there are two things that can happen. The command was executed successfully or it failed to be executed. So once the execution is finished, you generate the command execution response. So it's either an okay or a fail, right? And remember again, these are localized to the subsystem. So if the EPS, it will give you okay or fail, okay or fail. So you know where that response is coming from, right? Then you transmit those responses to the ground station. Very basic flow. Now, if the command is a scheduled command means that you don't want to execute it at this point. You want it to be executed at a future date, right? Which means your CubeSat should be able to store that command for future, right, reference. So we store the command in script file, right? And here you can see we are tokenizing the command again and extracting the execution time. Basically, this is a branch right here. I have to say at this point that this flowchart is not optimized. So there's some redundant features. For example, tokenize and tokenize here. There's a way we can share that, but anyway, let's make it work fast. So after you tokenize the command again, if I go to this EPS restart at a given time, I just want to get this and know when do I need to restart it. So I extract the execution time and then I start countdown. So basically this is going to be like a firmware thing. You can start a timer that counts down all the way to the future date, right? So once that countdown is finished, or rather elapsed, you fetch commands from the file. So this file right here, where you store the commands, right? You fetch that command, it's a FIFO, so first in, first out. Obviously, you want to execute the command that was received first in that order. After you fetch the command again, it's now like receiving a command, but not from the ground station, from a file. So once you receive it from a file, you tokenize and you repeat the same steps. Tokenize, validate command, set to specific subsystems queue, and execute it. So that's fast, very fast, in the sense that once you fetch that command from the queue, you follow whatever other commands that were followed by immediate types of commands. So there are some things I need to add to this flow chart. For example, what happens to the file when the command execution is successful, right? What happens to it? What happens to the command? Ideally, you want to remove the command from the file. What happens if it fails? You can retry because it's a highly critical system. We need to have like 100% success rate. So we need to retry that, right? So here I will like complete this flowchart later and maybe make a part 2 of what happens when the commands are executed, when they fail or not, whatnot. Right, so that's the flowchart. I've tried to be like as short as I can, as quick as I can. I'll show you the code that I've executed this, and the code is written in C. It's not optimized for embedded. So it's not optimized for embedded. This is like a pure playground. I was writing so that not in the future, like in a few days, I transfer it to the microcontroller, to the STM, right? Good. So whatever you see here is not embedded specific, but I'll just copy paste and make a few changes, maybe include some RTOS functions and whatnot. Good, but the template is the same. So command engine, I want to remove this. This was a test. Okay, so the bone, or rather the skeleton of this engine is this structure here. This structure is the skeleton. So the command engine is like how to say, it's a class, right? So obviously in C you're using struct, so it's a class. So this class has two things: subsystems table. I'll explain what that is. So these are lookup tables actually. Lookup tables, good. So subsystems table and commands table. We have the command attributes. We have the max response length. Does this thing? Okay, max response length, number of commands, right? So max response length is like max command length is like how long can the command get. I've put it to be 255. What's the maximum length of the response? What's the maximum number of commands that we can have? Right. So the next thing is the methods that this command engine has. So obviously we have mentioned checking valid subsystem, checking the valid command, getting the command length, organizing, token count. We are using a lot of memory allocation, so we will do some freeing of memory. Then we store the command to file. In the process, we can process the tokens, plus some other functions that are yet to be determined, right? So this is just a first draft of this function. Okay. So what is a command? I've called it a sat command T. So I've defined a new type that has the command type, which is immediate or scheduled, right? So command type T. Character command, this is now the actual meat of the command itself. So EPS, restart, then the time. This is where it's stored. Then command response. At this point, I'm not using it, but I'll be able to like generate a response for a specific command and store it. So this is what encompasses a command, a satellite command, right? Then these other things are just syntax issues. For example, I need a pointer to the satellite command, and I need a struct to type def to prevent me from like typing struct command engine every time I need to use it. So I type def it to a command engine, right? And then I have a function that creates a command engine class. And yeah, that's that. So I think that part is explained. Now I have member functions. Basically, just on a side note, the pattern that I'm using here to design this system is a class pattern, right? Class pattern. Class pattern is most common in C++, but in C you can use the struct and you can use function pointers. So function pointers have a ambiguous usage because they are not allowed to be used in flight systems sometimes, but it depends on how you write them. Anyway, so I'm defining methods that belong to this specific class as function pointers, right? So think of these as member variables. All right. So the next major important function is init, the command engine initializer, or the init function. So this init function takes a pointer to the command engine struct itself, and then it takes function pointers to whatever functions implement the methods that I want. Right, I'll show you how that works in a minute. Right, so let's start from the calling code. So whoever calls this code is the command engine creation functions, right? This is command engine create. Command engine create allocates memory for the command engine. Then if the memory is not null, if the memory is null, we return from the caller prematurely. And obviously, we need to log everything. Yeah, it's a rule that you're supposed to log every single thing in such a software system. Then next is we initialize now. Now in this initializer, we pass the instance, this instance right here. And then from there, we call the function with the instance, we call the function with the names of functions that have been implemented. So if you are not familiar with function pointers, again, it's okay, you can look it up, but the name of a function is basically a function pointer. So I have my general functions here that are that have the same signature as whatever is in the struct. Right. So for example, if I look at the get command length, it has a command engine instance. Command engine instance. This is right here. Then a const char pointed to a string. This right here. So they should have the same signature. So now I'm calling it the initialize function. I pass the names of these functions. These functions don't belong to anyone, but they take the instance. Right? They take the instance. It's a very nice pattern anyway, the class pattern of the, yeah. Right, so this function returns the command engine pointer to it, which is an instance, which is this instance. Okay. And then now, when you call, what happens in the initialize function? What happens inside here? So these are parameters of the function. Inside the init function, which is now the actual implementation of the init function, you have your parameters. Then you initialize lookup tables. I'll explain why I'm using lookup tables in a short while. Initialize the attributes, just the command length, the static attributes. Then you assign the arguments to this instance, right? So this instance check value subsystem is right here. So this function pointer should point to whatever the argument is. Should point to this. And the argument that you pass when you are calling the init function is this one. And where is this function? This function is implemented, check value subsystem is implemented up here. So basically you have pointed your internal methods to an implemented function. That is how this pattern works. Right, maybe I'll make a video, simplified video of how to implement this pattern in basic C embedded stuff. Okay, so that's that. That's basic setup. Now, the next thing I want to discuss is now the flow. Like where is the flow chart? Somewhere here. Yeah, flow chart. So get the command type immediate or scheduled. I don't think I have like checked this, but we want to check the command type, right? So in our get value subsystem, where is it? Yeah, get value subsystem. What does it do? So it takes a char pointer to the system, right? So if system is equal to null, obviously you have to check all your pointers. I did not even check the instance. So what I can do here is if inst, let's check that quickly. If inst is equal to null, then we return 0, right? Okay. So in one of those will return. If it doesn't return, then we can proceed. So validating subsystems. The function of this method is to check whether, because we have the COM, CPS, OBC, payload, and the ADCU. So if someone calls this function and says maybe GHY restart at maybe let's say this time again, we know that this subsystem is not a part of our CubeSat, so we should discard it. So that is what this function should do, right? So validating subsystem. Okay, so how do you validate subsystems? You can have a list of available subsystems in your CubeSat and then cycle through them, checking. Basically, you do a search in a given array of strings. The best way to do that is to use a lookup table, right? So a lookup table is basically nothing but an array of, for my case, is nothing but an array of strings that have the allowed commands, which is right here, subsystems table. If you realize it is basically it is a char that, right? Char double pointer, pointer to pointer. I don't know how to read that, but char pointer, whatever. It points to a point of pointers. That's the basic explanation. Okay, so we have the OBC, COM, CPS, ADC, and payload. So we cycle through this, searching. So for index is less than k and k is 0. So for each of these items, we do what we call string comparison. So we compare whatever has been passed, right, to whatever is in that specific index, right? We compare whatever has been passed, whatever is in that specific index, and if it's found, if it's equal to 0, okay, and see if you do a string comparison and two strings are found to be the same, it returns as 0. So if it's a 0, that system is valid, and I just flag that the system is valid. System offset, I was using it for some debugging issues, but it's fine. So if the system is valid, you print the subsystem is okay, should be subsystem is okay, and yeah, you return 1 from that function, which means the subsystem is valid. All right, simple. The next thing, you do the same thing for the command, but now I have like a small list of the available commands at this point. So you do a linear search basically. So there are ways to search there. You can do a binary search, linear search. You can do like a lot of different searches. But the one that is most reliable, and based on my research, the one that I've seen is most reliable in these embedded and flight software is a linear search, right? However much people don't like it because it takes time for if you have a huge array of elements, but it's reliable, right? It's predictable. So that's that. Perform a linear search. So for each of the elements in the command table, the lookup table, we compare it basically with whatever command we have passed, and if it's found, command valid is 1. The command valid is 1, we basically just debug and say the command is okay, return. Otherwise, the command does not exist in our CubeSat. Good. The next thing is I'm just discussing these functions in passing. Get command length is basically we have a command. We want to know is like calculating the length of a string. Like how long is this command, for example? How many characters are those? That is what this function does. Pretty basic. Until you find a null terminator, you keep incrementing the count. Simple. Then you return that length. Now the matter of all these things is the tokenize command, right? Tokenizing is basically we are splitting this command. Let me remove all of that junk. We are splitting this command in the into EPS restart, and then the last thing we want to split into is this time right here, like that. So this is what that tokenized function does. These are tokens, like token 0, token 1, token 2. Okay, so at the moment, I don't care about whether the function is immediate or scheduled. I'm just handling it the way it is, because you can see there's nothing that is being done here. Basically, I'm just printing output to the standard stream, standard out stream. Now, to tokenize, we don't want a change in the original command that was passed. In C, if you tokenize a string, the string that you passed will be modified. So what to do, you copy whatever you have received into your own local copy that you work with. So that is what we do here. So string copy from the received command to this copy right here. I use +1 to add for the null terminator. So then we pass the command. Basically, what delimiter are we using? I'm using a delimiter that's a space for my case. So this is a space, this is a space, this is a, okay, there's no other space. So this is 1, 2 spaces. So 2 spaces in my command engine means 3 arguments, right? 1, 2, 3, or 3 tokens. All right. So we want to count the number of arguments to be extracted, which means I will calculate the number of spaces that I have right here. So if basically the temporary string is the copy of the command, if it's not equal to space, or if it's equal to space, I increment the argument count. So it will count 1 space, 2 spaces. But now I'm interested in the number of tokens. So these are 1, 2, 3. So if I count 2 spaces, I say 2 spaces plus 1. I get the number of argument count. That's why there is an argument plus here, args count plus. And then I have to store these tokens somewhere to use them. So basically I allocate memory for a pointer to character pointers. Basically something like this. So my tokens will be stored somewhere. So they'll be stored in is an array of strings. Be token 1 somewhere here, token 0 obviously, and then token 1 etc, like that. Good. So I do that, and then basically I do what is called tokenizing or splitting a string in C, and then which uses string token or strtok right here. You pass the command, you pass the delimiter, which is a space in my case, and then for each token you store it in the result, right? So you see right here, result index, you duplicate that token and store it. All right. Next, at the end of the day, we want to store a null terminator to our result, to this char double pointer, right? So that we can like know the end of the string. We'll use it later on to count the number of tokens that we were able to extract. Okay, so I'm moving as fast as I can to explain because it's very basic code, but it's like detailed. And there are other ways to do it anyway, but yeah. So process tokens basically takes whatever tokens we were able to extract here. So you realize that this function returns a pointer to our tokens. So I take those tokens, a list of strings, and then I check now if the system is valid. I know that the first token is the system. Basically, this is the first token, right? I check if it's valid, I check if the command is valid. Then if both of them are valid, that's where I send now to the queue. Basically, where I am in this function, I am right here. That is where I am. So send to specific subsystems queue. As you can see, it's not implemented. Is that to do? Okay, these other functions are like support functions. Like for example, get token count. You just count the number of tokens you have. That's why we are putting null. Where is it here? At the end of the list of tokens. All right, so the next thing we free memory. So we realize that we have allocated the memory for results. Where is it? This guy. We want to free that memory. So we want to free 2 types of memory in that case. We want to free the memory that is inside the string, and we want to free the memory that is the character holding the strings, right? Okay, cool. So that's that. Store command to file. This is not like a very complicated function. You just open a command text file and then you put your string there, this command right here. Just append it to the file. Simple. Yeah. So I've written this file. I had written this code like without the pattern, and then I have refactored it to use a pattern. I have tested it without the pattern, but I have not tested it with the pattern. So to test it, let's see whether we can actually, whether it will fail or not. This video should actually end. It's too long. It's becoming too long, but let's see. So create. We need to call this function creation function, right? So I'll just delete this, and let's say maybe delete. Okay. Let's create command engine create. So this will be command engine cmd engine that is equal to this should return a pointer command engine create, right? So when you call this function, it'll come into this, instantiate the command engine and do all of these things. Now let's see whether we can run this without an error. So I'll open this and then compile. Compilation is successful. Then we run it. At this point I don't expect any output, so it's in test. Good. So we are able to run it. Good. Now let's try like passing with an PRS command. I've created a simple command, count command 2, which has schedule type, and the command is right here. Comes restart at this time. Okay. So I'll say now the command engine. I can call a function that is called. Which function should I call first? Let's see. Process tokens, not tokenize. Actually, let me do this. Let me follow okay, yeah, let me follow this command. I've written this code before. Let me follow these steps. Command engine is equal to command engine create. Do that. Then you say cmd engine. Okay. Process tokens. So what does that do? Process tokens. We need to tokenize somewhere, so we need to tokenize here. So I'll copy this. Let's see whether this works. So this will be cmd engine tokenize, right? Tokenize takes an instance, and then it takes a command engine, which is an instance of this command engine, and then it takes the tokens. No, it takes what? Tokenize. What does tokenize take? The command. Yeah, it takes the command. Yeah, it takes this command here. Okay. So command engine, when you say process tokens, we expect it to say command engine, and then we pass it our list of tokens, right? Which is, let me rename this to something that is more readable. Tokens. We pass tokens here. V list. Right. And then we free the memory. So we say command engine free memory. You give it a pointer to memory, so which memory we want to free the tokens that have been allocated. So I hope this works. Let's see whether it works. If it doesn't work, it's fine. You can fix it. Oops, yeah, error. Incompatible type for argument 1 of CE tokenize. So CE tokenize is taking an instance, tokenize command engine cmd2. Let's see. Create return instance. I don't know whether you can see that, but let me do this again. The compatible type of argument one of C tokenize cmd1. Who is calling that function? Oh, it's me. I need to comment that out. Try that. Good. We have no errors, so let's run it. Test. Good. So perfect. So you can see that the type of that command is a scheduled command, obviously, right? So it's just checking what has been passed. It's right here, scheduled command. Then the other thing is valid. Passing the command, it just tells you what command it has received. Validating system, subsystems comms okay. Validating command restart. Okay, so this command is okay and this subsystem is okay. Command check done, ready to process. So it means we are successful at passing the command. Commands check done, ready to process. Perfect. So yeah, so that's it. That's part one of this command engine test. I'll come up with like a list of test units because I need to test like bad commands, bad times, like limits. There are a lot of things that goes into this. But yeah, thank you if you have watched this far. Thank you for watching, and I don't know, like the project or follow the project or just contribute if you can. Code designs, whatever. Hit me up. I'll leave the link of the project or to the project in the description. Yeah, and that's it. Thank you, and see you on the next one.